Hello dear students, I'm once again inviting you to this series of mathematics problem solving. Last session I taught you an introduction of logarithm, and if you followed me clearly, then you can now be able to define a logarithmic format from the exponential format. Now today I'm going to proceed with another part of laws of logarithms. There are four laws of logarithm which we should always use to solve our logarithmic expressions. The first law is called logarithm of product. The first law is called logarithm of product. This is the first law. And the second law is called logarithm of quotient. Okay, and the third law is called logarithm of power. Okay, and the last law is called the logarithm of root. Okay, so these are the four laws of logarithm which we are going to use throughout this part of logarithm expressions. Now today I will start with the first law, logarithm of product, and the quotient law. Okay, now the law says, now today I'll start with now this is product logarithm of product. Now logarithm of product. Now this one says, assume you have a product of two numbers with a common base. Now assume or let you have logarithm of number A then times B, okay, with a base of B. With this base of B, with B base. Now the law says logarithm of a product of two numbers is always equal to logarithm of first number A, then base B, then plus logarithm of the second number B with base B. This is the general formula of logarithms of a product of two numbers. Now example, assume you have this question. Example, let me write this example. You have this, okay, logarithm of 4 times 6 to base 2. Okay, this one can be now written as logarithm of 4 to base 2, then plus logarithm of 6 to base 2. This is how you can express that format. Okay, now since I've already given you now the general formula, now I hope we can proceed. Now assume you have given this question. Now for example, you have given this example number 1. You have given maybe logarithm of 4 times 8 to base 2. Now find the value. Find the value of logarithm of 4 times 8 to base 2. Now solution. The formula says logarithm of two numbers, maybe a times b. This one is equal to logarithm of the first number to base b, then plus logarithm of the second number to base. Okay. Now from this one, now I can say logarithm of 4 times 8 to base 2. Now this one is equal to logarithm of 4 to base 2 plus logarithm of 8 to base 2. Now what's the value of this one? What's the value of logarithm of 4 to base 2? What is the value of logarithm of 4 to base 2? And what's the value of logarithm of 8 to base 2? Now this is what you're going to find. If you refer the general formula of logarithm format, which says exponent is equal to logarithm of a number to base. Okay. Now from this one, you can say we are looking for exponents. Okay. This means you're going to be looking for exponents. Now here we are going to find an exponent of this number. Okay. Then we plus exponent of this number. Okay. And here is the formula. Okay. Now from the first expression, logarithm of 4 base 2. Okay. Now a number, you have given a number of 4 with a base of 2, and exponent we don't have, and this is what exactly you're looking for. And the general exponential format says base power exponent is equal to number. Base is 2 and exponent is nothing, is what we are looking for, is equal to number, which is 4. Now express 4 in the format of base. I mean with a base 2. Now 2 power exponent. Now if we express 4 in terms of base 2, then we can get 2 power 2. Now with a common base, now exponent is 2. Okay. Now from logarithm of 4 base 2, this one is equal to 2. Now here will be equal to 2 in the first number, then plus. Okay, now let's move to logarithm of 8 to base 2. Okay, now from there, now I can also say, now also I can say there that, okay, now exponent, now I can say base of exponent is equal to number. Our base there is 2, okay, is equal to, okay, our exponent, which we don't have, our number, which is 8. Now express 8 in terms of base 2. Now this one will be equal to 2 exponent, which you don't know, then 2 power 8 is 2 power 3. Then our exponent is e will be equal to 3. Now here we have 3. Now conclusively I can say the value of logarithm of 4 times 8 to base 2, the answer is equal to 5. This is the solution of the question. Now another example. Now let us try another example here. Okay. Now let us try another example. Now assume now you have this one, logarithm of 0.01 times, okay, 100,000, 1, 2, 3, 4, 5, 100,000, then to base 10. Okay, now solution. Okay, now according to the formula, logarithm of 0.01 times 100,000, okay, to base 10. This one is equal to logarithm of 0.01 base 10, then plus logarithm of 100,000 base 10. Okay. which now will give us, now find the value of logarithm of 0, 0.01 dot 10. Now from the formula, we know exponent is equal to logarithm of a number to base. Okay, now from this expression, now I can say our number is 0.01, okay, which is equal to 1 over 100. 1 divided by 100, we get 0.01, which is equal to 1 over 10 squared, which is equal to 10 power negative 2. Okay, now from there, we know that always base to our exponent is always equal to number. Our base is, from there, our base is 10, okay, and our exponent is negative 2, which is equal to number, which is 0.01. Now of course here we have exponent of negative 2. So for this case, this whole value, this one, this value, the whole value is equal to negative 2, because this one is always equal to negative, is equal to exponent. Now let's move to another value of 100 thousandths. Okay, now this one can be written now is equal to 10 thousandths. Sorry, let me use here a blue color. Now 100 thousandths, this one can be written as 10 power 5. Okay, now from this one you can say our exponent is 5 and the base is 10. Now from this one I've already found the exponent, which is 5. Now this expression, if you express this expression as a whole, you can get this one is equal to 5. Now I can say, conclusively I can say now logarithm of 0.01 times 100 thousandths to base 10, this one will be equal to negative 2 plus 5, which is equal to 3, which is the answer. Okay, now after that, then I'm going to show you on logarithm, the second law of logarithm of quotient. Okay, logarithm of quotient. Logarithm of quotient. Logarithm. Okay, this one. Logarithm of quotient. Logarithm, which is the second law. Logarithm of quotient. Quotient, another meaning is division. Logarithm of division. Somebody might say that. Okay. Now, the formula says if you have a logarithm of maybe a divided by b with a certain base, this one is always equal to logarithm of a to base b minus logarithm of b to base b. So this is just an opposite of logarithm of product. So instead of plus, now we place a subtraction of operation. Okay. Now, for example, if you have logarithm of 8 divided by 4 to base 2. Now this one can be expressed as logarithm of 8 to base 2 minus logarithm of 4 to base 2. This is the general expression and how we can deal with logarithm of a quotient. Now example number 1 on this part. Now let's consider you have example number 1 of this part. Now assume you have given logarithm of 27, okay, divided by 3. Okay, divide by 9. Let's say this, divide by 9 to base 3. Find the solution, find the value. Now solution. Now this one can be expressed as logarithm of 27 divided by 9 to base 3. This one is always is equal to logarithm of 27 to base 3, then minus logarithm of 9 to base 3. Now this one, now find the value of this one, find the exponent, exponent value of this one. We know base power exponent is always is equal to number. Okay, our base is 3, power exponent is always is equal to number, which is 27. Okay, now 3 power exponent, this one will be equal to 3 power 3. Now exponent is equal to 1. Now exponent is equal to 3 if you compare. On this one I can say now first exponent is equal to 3. Now what about this one? 9. 9, 3 power exponent is equal to number 9. Now from this one, 3 power exponent is equal to 3 power 2. Now exponent is equal to 2 in case of 9. Now from this expression, now I can say logarithm of 27 divided by 9 power 3. This one is equal to logarithm of 27 base 3 is equal to 3. Then plus logarithm of 9 base 3 is 2. Now the answer is 5. That is how you can handle expressions of that kind. So I think I should okay, maybe let me give you another example if I'll not offend you, but let me check. Okay, I think there's no need of giving you another example. Of course, there are same procedures. With the same procedures, you can be able to drive any kind of question. But in case you have any difficulty on this part, please check me on my email, jprogramming@gmail.com. jprogramming@gmail.com. Now for today, I say bye bye.